All right. Yeah, thank you all for being here. So basically, I'm going to talk to you about Dataiku, what we've done for a company called Voyage Privé. We actually used images, customer data, and product data to build their recommendation engine. And this is basically what I'm going to talk to you about today. I'm a bit disturbed because I tend to not to say that I used to be a trader. It's more cool to say that I'm a data scientist now. So yeah, that's going to be the agenda for today. Brief introduction about who Voyage Privé is, Dataiku also, what Dataiku is, and then I'm going to go through the exact methodology that we follow to actually tackle that problem for them. So using basic, I would say, recommendation techniques and recommendation scores to build a first model, and then how we did improve that model by using their images in the form of deep learning, as everyone understanding nowadays. So about Dataiku. So Dataiku is a French company. Always difficult to pronounce that name for English people. So it's Dataiku, but you can say Dataiku. It's fine as well. We've been founded in 2013, 4 years ago. We've got offices now in London, in San Francisco as well, in New York, and obviously in Paris, 85 people. We're currently recruiting data scientists in the UK. I'm actually leading the data scientist team in the UK, so if you are looking for a position or something, please do not hesitate to contact us. So what do we do exactly at Dataiku as a company? We provide a software, an end-to-end platform basically to actually tackle data science problem, tackle data science project from the end to the end, from one end to the other end. So from ingesting data to actually producing results. We all know that 80% of data science project, unfortunately, never goes out of the lab for various reasons. We tend to think that with our solution, it is actually much easier to put things into production, which is, in the end, the overall goal of the business. Voyage Privé. Voyage Privé is it's a French company as well. It's e-business vacation seller, basically. So you're going to go. I'm pretty sure that most of you actually know that website. It's a very nice website where you can actually buy your next trip and your next holidays. It's been founded a bit more than 10 years ago now, and in 2015 they posted a nice revenue of €500 million. They've got 18 million of clients in, I think, mostly in Europe, a bit in Brazil as well. 4 million of those clients are actually in the UK. So it is very likely that some of you have actually used that website. The website is very nice. As you can see, they put lots of emphasis on the images, on the display. And their main goal when they do that is to actually make sure that people dream when they get to the website. They want you to actually scroll into it, think about your next holidays, because in the end what they want you to do is to buy those trips. However, they don't want you to scroll too much into the website because dreaming is good, but they probably are more happy when you actually buy the product. So they've got 80 million of clients. I think it's actually 1 million that we would call active clients. An active client in our own methodology would be someone who has used the website in the last 30 days. Just connected to the website. Didn't actually buy something, but just connected to the website. So they've got 1 million of active clients, and then they've got something like 1,000 sales every day available on the website. So as you can see, it is a huge matrix, a huge problem to tackle. How can you score every sale, every product to every client? So this is the stuff that we actually did for them. Some specificities about the website, and that are heavily related to the technicalities of the problem and the difficulties of building that recommendation engine. Unlike, the main, I would say, main provider of recommendation scores like Amazon or PriceMints and stuff like that. First of all, those products are very expensive. It's not like you're going onto a website where you want to buy a dress or a pair of shoes or something like that. It's very expensive. So the decision process is very different. It's also very different because the sale is not going to be, the product is not going to be stay there forever. The product is actually available on the website for a week. 90% of it, it's available for a week. So for me, as a data scientist, I've got that huge matrix where I've got lots of products, very expensive, so few interaction between those products and the client, and those products are actually not going to stay there forever. So it's dynamic, very expensive, few recurrent buyer, all the classical approach that you would actually went through would fail. So we needed to take that as a good starting point to think about the problem. And again, one last thing regarding the specificities, and it's very important. It's the size of the images and all the work that they do to actually choose very nice visual for you to be on the website and come back to the website. So the methodology itself, before we dive really into pre-processing, feature engineering, and stuff like that, this is the methodology that we follow at Dataiku usually. We tend to think that you need to start small with couple of ideas, and then iterate from that. So one of the first thing is we did provide them the platform, and with the platform, it is pretty easy to actually acquire all the data. In terms of infrastructure, they have an Hadoop cluster with Cloudera, 5 nodes on that cluster. One of the biggest database is basically probably 2 billion rows because they record every action of the user on the website. So we had access to all the client data, all the product data. We started to explore those data, try to understand that. We were working with people from the business as well because I used to be a trader, so I had absolutely no experience regarding e-business companies and stuff like that. So being able to work with someone from the business is actually pretty helpful because he will tell you, well, you probably need those kind of data, those kind of variables, those kind of features to actually tackle that problem. And this is where you're going to find them in our system, in our database. So basically, with that platform, also we give access to different type of profile, data scientists, and also data analysts. Those guys were actually able to do the data preparation, where they've got some data that are quite not very clean. They can do that by themselves, and then we data scientists from Dataiku, we came in to probably work a bit more on very advanced statistics, model creation as well, and then we evaluate and we iterate until we were quite happy with the result, and then we put that into production. Okay, so let's talk about how we did build that recommendation engine. So again, we started with a very simple ideas, and then from those simple ideas, we started to grow. When we think about recommendation techniques, the main techniques and the main thing that you can think of are quite obvious. Again, data science is not magic. We didn't invent anything new or completely amazing. When you want to do some recommendation, one of the first things that you're going to do is think about the popularity of a product, popularity of a sale or something like that. If this is very popular and you come to the website, I'm going to display it to you because it is likely that you're going to like it. It's the same for retargeting, very heavily used on the internet right now. If you saw something before, I'm going to show it to you again because it is very likely that you're going to like it. And then you can incorporate some external factors, like right now we are in April, probably we're going to be in May in a couple of days. So now it is very likely that you will want to buy your holidays for the summer. So I'm not going to display you any ski trips or stuff like that. I mean, I could, but would be not very smart, I think. And then you've got some more advanced techniques. So those techniques have been popularized by companies like Facebook and particularly Amazon, obviously, collaborative filtering and content-based. This is big names for very simple concepts. Let's say that you want to know if you are going to, you want to go to the cinema next month, or probably 2 months ago, you wanted to go to the cinema and you wanted to know if it was likely that you would like the film, the movie La La Land, for instance. What do? You go to the pub, you start to speak with your friends, and then you're going to ask them, have you seen that movie? And if he says yes, and I did like it, then you're going to say, okay, all right, you did like it. It is very likely that I'm going to like it as well, so I'm going to give it a go. This is the main idea behind collaborative filtering. Basically, what you want to do is to identify a similar profile of users. Basically, that guy went to Thailand, that guy as well, that guy went to Brazil, that guy as well, and that guy went to China. That guy didn't go to China, but it is very similar to that user, so let's talk to him about China, because it is likely that he is going to like it. This is the main idea behind collaborative filtering. Then you can translate that into a matrix and vectors and stuff, and do some mathematical stuff with that, but this is the main idea. For content-based, it is quite the same as well. I am a very lucky data scientist at Dataiku, so I've been involved in a lot of traveling the past few weeks. I've been to Berlin, to Warsaw, to Bucharest. What all those cities have in common? They are cities, first of all, Eastern Europe. This is the kind of concept that are really, that really define those cities. It's the content that talked for those cities. So again, from those different products, we're going to extract some main themes, like is it a city trip, is it a sun and beach trip, is it a ski trip, stuff like that. And then we're going to measure the similarities between those different products in the exact same way. And then if I've been involved in trips like Bucharest, Berlin, Warsaw, and stuff like that, then it is very likely that I will go to Prague in the next coming weeks. Actually, I would have been wrong, because I'm not going to go to Prague. And then, so you've got all those different scores, basically, using some popularity, some retargeting, some external factors, collaborative filtering, content-based as well. But you're not there to actually choose one of them or choose one method against the other. We tend to think, and we actually understand now, that one of the best methods, one of the best approaches to actually use those different scores, use those different, because all those stuff, collaborative filtering and content-based, are machine learning algorithm in a way. But what you can do, and what is probably the best thing to do, is to use that as features for another model, what we call a meta model. A meta model will actually use all those different models, and it will basically learn from the different mistakes of all those models. And then with this, you've got a very powerful engine, and you start to have a very nice result. A bit of technical things. How did we build the test set? What kind of machine learning model have we used? So to build the test set and the train set, which is key again in data science. If you don't do those steps properly, again, there's no magic. It's not going to work. So we took all the different, for a given period of time, we took all the given couples, product and clients, and the question was, did he actually buy this product or not? And then from all those different couples, we build the training set, and then the task of the algorithm was to actually try to predict the likelihood of purchase, and nothing else. Could have been the visit and stuff like that, but no, we decided to go for the purchase. So we did some what we call negative sampling. So for each buy, I need to each purchase, I need to put a few no purchase in the test set from that same user. And in terms of for basic logistic regression. Why? Obviously because all those different scores are already machine learning, techniques and bring some stuff into the modelation part. If you put some nonlinear methods on top of that, it is very likely that at some point you are going to overfit the model and you're going to learn some stuff that are irrelevant to the problem. So going for a simple logistic regression is actually quite efficient. And also because if you go for, again, a nonlinear method, you're going to just improve very slightly the performance of the model. And here, this is not a cargo competition. We're not here to overfit the data set. We're not here to have the best performance. We're here to put stuff into production. And in the end, this is why we went for that, just to make sure that we don't overfit and to try to make things as efficient as possible. And in the end, what we had was probably a re-rank. Yeah, we basically the overall approach is similar to a re-ranking approach that Yandex, if you remember the Yandex challenge a couple of years ago. We could have gone further, especially try to predict the visit. Oops. No. Okay. We could have tried to predict the visit, and also try to complexify a bit the problem and say, okay, all right, is it going to buy? Is it only going to visit the product, or is it not going to actually see anything of that? We could have done that. The only problem is, like for every business use case, you don't have the time to test and try everything, but we would have loved to actually do that. Some of the limitation, obviously the order of the display of those different products on the website is very important, and because when you connect to the website, I can't know what was the first thing that you see, and it's always re-ranking and re-ranked. And I had no idea about when you connected that day what was the first cell display on the website. So I couldn't say if you actually scrolled to see that product or if it was one of the first one available to you when you connected to the website. So that was one of the limitations of the approach. But anyway, doing all that using customer data, cell information, doing the stuff pretty cleanly and neatly. We were able to finally batch score every night this million of clients against those thousands of cells, and then in the end, after a couple of weeks of A/B testing, we went live. I think 1 month or 2 months after that, and we posted a nice +7% of increase in the revenue. So we were quite happy with that. Also, the client was quite happy with that. So they decided to say, okay, yes, let's go for even more complex problem that are related to the image. Because, as I said in the introduction, the image is very important on the website. It's basically going to drive the behavior of the customer. Basically, one of the basic questions for them was to actually understand what's the difference between, what will drive the behavior of someone who wants to buy a ski trip? Is it going to be very influenced by that image or by the last one? And it's the same thing for the Sand and Beach pictures. So the only problem is when I've got those images on the website, I know me as a human being that this guy is actually skiing, and I can say that I think this is Nice, that one, but I'm not quite sure. But because it's me as a human being, how does the computer know about that? For the computer, it's just 1 and 0s because it doesn't know anything about it. So it is actually quite hard to extract some information from those images, but this is actually the key. I need to be able to know what's on the image. And then from those information, from those images, then if I can label those images and say, okay, there's a ski field over there, there's a boat over there, and stuff like that, then I can start to create profile for all of those images, and then try to actually extract some value out of that. So the real problem in here is to be able to label some raw data, some raw images, so that I can build a profile for each image, and then a profile for each customer. So how did we do that? We used some deep learning techniques. But first of all, couple of things regarding deep learning and why don't we do more deep learning right now at the moment. Usually organizations are going to tell you, well, I don't have the resources, either regarding the computer, I don't have a GPU, and then if you don't have a GPU, yeah, then it can stay forever. I don't have a deep learning expert. I don't have labeled data, which was basically our problem. And, well, it's related to the GPU. I don't have time for the model training. Yeah, this is the kind of stuff that we do. So at Dataiku, we went, because this is the kind of stuff that we hear a lot. So this is the kind of slide that we went to client with. Basically, if you're sure you want to do some deep learning, you need to ask yourself those questions. And in the case of Voyage Privé, we knew that they didn't have any labels. Basically, we needed to find some labels, some image already labeled, and then use those image labeled to build or extract actually the kind of information that we were looking for. So basically, this is called transfer learning. It's transfer learning methods. Transfer learning is going to be key in the next coming years in terms of deep learning application for business, because the idea behind it is quite strong. If I have, and in the case of Voyage Privé, I have those raw data with no labels, unfortunately. But if I go to the academic space, I can find that database, that place database from MIT, where I've got 2.5 million of images and 205 categories. So that means that for all of those images, you're gonna be said that, okay, there's a tower, there's a skyscraper, and stuff like that. So this one place is coming from the academic, and some database is coming from. I'm not sure if it's coming from the academic. I can't remember where it's coming from. Anyway, it's available on the internet. And then yeah, basically you using those models, those already pre-trained models. You can say if I give this image to the model, it will tell me, okay, all right, it is very likely you've got a probability, a good probability that there's a swimming pool and an in and an outdoor on the image. And it's the same right there, good probability for a tower, good probability for a skyscraper. Unfortunately, when you are Voyage Privé, those kind of information are not enough. You need to know much more about that. You need to know that, obviously, yeah, there's a swimming pool, but I need to know that there's a beach in the background. I need to know that there's a golf course as well here. And this is probably an auto. This is the kind of stuff I need to know because I'm a vacation retailer. I need to have as many details as possible. So how transfer learning is going to help you doing that? Well, basically, the idea behind transfer learning is with some training, if you were trained to learn something, and then if we recalibrate you to learn another thing, basically you will be able to do it. That doesn't really make any sense, but let's use me as an example. My mother tongue is French. I know how to speak. I know how to construct sentences and stuff. And with years of training, I now can speak English. This is transfer learning. Regarding technicalities, we used a very famous algorithm, VGG16. All those first layers, we actually freeze them. We didn't touch them. It's kind of stuff that the model learned by itself, and what we retrain is just the end for it to actually learn a new task. Yeah, so in the case that we used an already pre-trained model. We transferred the knowledge from the different images that we had. Basically, the new task that we were willing the model to learn was, I think I forgot to show you this. Yeah, so basically the new task that we wanted the PLAS model to learn was those 300 categories from the Sun database. Because if I've got 200 categories plus another 300 categories, then when I label that kind of images, then it will be perfectly labeled. I will have lots and lots of information. So this is why we needed to actually retrain and transfer the learning from that place database to a database where I've got more and more categories. So this is a good summary of what we did. Take the place database, retrain it on the send database, and then we were able to label the images from Voyage Privé. This is the methodology that we use for them. And then what does it look like? And then what do you do when you start to have some labeled images? So you had that kind of image, and now you are able to the model that is transfer learning model is actually able to tell you now that there's a swimming pool, there's a chalet, there's probably an hotel somewhere, there's an outdoor. It's the kind of information now that are quite useful for you. The only problem now that you have is that some of those information are quite recurrent, especially on that image. If you look at it properly, you can see that the model is going to tell you, okay, there's a conference center, there's a conference room, this is probably also an auditorium, could be a ballroom or banquet hall. Basically, all those different topics speak about one main theme. It should be conference, it should be the topic conference. So what we did is from all, and it's kind of the same in here, so from all those different labels that we put on all of these on all of these images, we wanted to construct and to build some big overall topic on top of that. So how did we do that? We did mathematically what we call a matrix factorization that will let you extract some big topic out of lots and lots and lots of labels. Again, we had nearly 600 labels, and we wanted to actually reduce the kind of information that we had on those images to something like 30 big topics. We did that with an NMF. Why the NMF? Because it's much more easier to actually interpret the result, because the NMF will give you only positive coefficient, so much easier. And this is why we didn't go for LDA or other methods. And now it starts to be magic. Now I know on that image that I've got a big theme, which is golf course, fairway, putting green, obviously. I've got another big theme that is hotel, another one that is swimming pool, and then the last one, which is beach. The main difference between this and all the different labels is that those big topics, as they are now, are much stronger than only labels by themselves. They are, they speak a lot more, and the probability assigned to it is actually much more interpretable. And it's the same for that one. Instead of having lots and lots of labels, again, I just have two main topics which tell me, okay, right, you've got tower, skyscraper, office building, and another thing over there. The result were quite outstanding, because when you start to do that kind of stuff, it is always a bit complicated, because you start to search, you do the coding, you test things, you test ideas, but then you never know if it's going to work or not. I'm sorry, it is not the best image I could actually have. We built again in the platform a nice web app where you could actually see those results a bit clearly, but I'm going to try to explain that at my best. So the first column is all the visits that one client of Voyage Privé did in the past week, the past month. The second column is basically the recommendation stuff that we would recommend to him without the images. So we knew from the visits that this guy mostly shows stuff where he wanted to go to France, and basically where a pool was displayed. This is the kind of stuff that we can see us as human beings seeing his visits. The recommendation engine techniques that we did at the first phase, that I talked about at the first phase, was able to capture the fact that the guy wanted to go to France, or at least to some European countries. It didn't, recommend stuff like in Brazil or in China, which was good enough to at least increase the revenue as we saw. But it couldn't capture the fact that this guy was really willing to see some pools. And then the third column is the recommendation engine, just by using the transfer learning methods, then the topic extraction and stuff. And we could see that the algorithm was now able to capture the fact that the guy was willing to see some pools. Because as you can see, in all of them, you've got pools. And when we saw that, we were quite happy. And the last one is actually combining the first machine learning model, the first recommendation technique that we built, and the images as well. And now you can see that we're able to capture the fact that this guy is going to France, and also he wants to see pools. Because the problem again with the images is that the model can extract some information from the images, but it doesn't know where this guy wants to go. So you're going to have some swimming pools, but if you can have a look at it, the first one is a swimming pool, but in Dominican Republic, which is not very good, or in Italy, or in Morocco, or we know that that guy wants to go to France. So when you combine both, then you are really powerful. Same example over there. That guy wanted to go in Spain. The main theme of the product that he was scrolling in were sun and beaches, and again, pools were displayed, and it's the exact same thing. With the recommendation engine, we can extract the fact that this guy is going to go to Spain and to see sun and beaches stuff. With only the images, we can capture the fact that he wants to see pools, and when we combine both of them, then this is where we start to be really efficient. And then, so this is obviously very valuable for the business, but that's not only for the recommendation engine. We were able to go to the marketing and went with very counterintuitive methods, I would say. And we asked them basically for a ski trip, which kind of images would you actually display on the website? And I mean, when I went to them, I was a bit cheating because I knew the answer. But when I saw those results again, I was pretty amazed, because when you think about this stuff, you say, okay, all right, a ski trip, I'm going obviously to display the guy that is enjoying himself on the ski fields. But when you look at the results, this is actually not what people tend to want to see when they're looking for ski trips. As you can see, the ski valley, the snow fields are the stuff that are really not attractive for clients. What is very attractive for clients is actually the inside of the hotel room, the bedroom, and basically all the after ski, the post ski activities. So when you go to people that they're just going to display that kind of stuff because it makes sense, and you actually show that to them, again they were very, very happy. What could be next? Well, what would be next would be to actually say, okay, right, what's a good image? A good image for me is definitely not going to be a good image for you. A good image for me that will talk about Africa could be some elephants, but could also be some beach again. So from all those information now, as I'm able to extract those topics, those information from those images, I can build user profile, and I can say that this guy basically when he's willing to see some stuff about Prague or about cities, he wants to see those kind of elements. So basically, I can display the exact image on the website when I know that you're on the website. So it is very personalized choose of images when you are on the website. So that would be the very next step. But we're not there yet. But this is the kind of stuff that now that it is actually quite possible to do. To conclude, do iterative data science. Start simple. Do some very basic stuff. Don't try to reinvent the wheel or be involved in products that are projects that are unmanageable. And then when you start to have those small steps, and you can build on those small steps. And then about deep learning, well, yeah, do some deep learnings. I think it is amazing. I think we've got all the capabilities to do that right now. And don't wait to have some very amazing, talented people to do that, because just using some transfer learning and pre-trained models from the academics background, you can actually achieve tremendous results. Again, transfer learning is cheap, it's fast, and I used to be a trader. I don't have a PhD, and I can understand the concept. I definitely cannot recode all those things from scratch by myself, but I can understand the concept behind them, and I can then apply them to a business use case. Well, thank you, and if you have some questions, then I'm very happy to answer. But please wait for the microphone so we can record everything. Thank you.
The major problem for companies who used such kind of images wide variety is labeling and tagging.
Yep.
And a lot of them, they used manual. They hire somebody who do that manually.
Yeah.
And you achieved it through what you call it pragmatic deep learning, and I understand that it is a kind of convolutional network, as you mentioned it.
Yeah.
So I don't know if there is. And you mentioned the matrix factorization.
Yeah.
Is this the algorithm you used?
No, so the algorithm that we used to label the data was the transfer learning approach. So we had some
sorry?
transfer learning.
Transfer learning.
So the transfer learning approach, again, it's the fact that I've got some images already labeled from the academic or from someone that was, one day bored and then decided to label all those images, and then he trained a model on top of that. Me, what I'm going to do, I'm going to take that model, because that model, what is deep learning? Deep learning is neural networks. It's a fancy word, but it's very powerful because it's just learning a new representation of things that is probably most efficient than the way us as human beings are doing it. But then you can retrain the last layers of that. And just retrain. You don't retrain the overall representation of stuff. You just retrain the front end layer, I would say, and then you can achieve some powerful things doing that.
Okay. The other thing is about meta model.
Yeah.
So you mentioned ensembling. I understand it because
meta model is basically it's basically what we did was kind of assembling. We had some different scores from different traditional recommendation techniques, and we ran logistic regression on top of that.
Which programming language you
Python.
used? Python. And the packages.
Well, scikit-learn.
Sorry?
Scikit-learn.
Scikit-learn.
To build all those scores, actually, I'm cheating a bit. To build all those scores, we did that with SQL. It's actually much more efficient to do that in database. And then for the logistic regression, we use the logistic regression from our software. You just do that by clicking, but you can do that with Python and scikit-learn. Or actually, it's been recorded in now that Voyage Privé has Spark on their cluster, so we're using the logistic regression from Spark. From MLE then.
Okay, thank you.
I think. Whoa.
So you use deep learning to predict the images. So I was wondering if you took in consideration use any of the machine learning as a service APIs that are out there? And well, what's your opinion with following the approach of deep learning approach, or just using machine learning API, for example?
So again, doing stuff with the with API. Usually, when I do that talk, I've got a longer time, so I can talk about APIs. The main problem with APIs is that for business, you're not going to have enough categories. So you have to use models where you know that you're going to have as much information as you need on the image. In that case, we went for an API. We actually steal one API as well, because it is pretty easy. You can just label a couple of images, and then you do transfer learning on top of that, and basically you store the API. This is completely illegal. You shouldn't do that.
I think we have time for one more question.
Did you have any problems with like cold start, and how did you get around it? With like the cold start problem where you've got no data on your customer before they've even clicked into anything? Did you try and get around it?
So regarding so to avoid that problem, we basically when we built the train set, we took customers that went on the website the last month, which was much more easier, because then you obviously know that that guy was on the website. You've got some activities, and then you can use those activities to build a customer behavior and stuff like that. So all the non-active users, people that haven't been on the website the last month, we didn't actually interact with them, and we didn't even use them. We didn't even score them on the batch scoring. We did score someone if you went to the website at least once last month.
Okay, that's probably all we have time for.
No problem.
So can we just give a big thank you to Alexandre Hubert? And